Hi, my name is Adewale Odunayo Grace. This is my presentation on K nearest neighbor and classification tree. Let's dive into it. Data used for this analysis is prostate cancer data. And after the preprocessing of the data, checking for missing entry, the distribution of my response variable, I move on to identify the strongest predictors because this data is actually high dimensional. It has 500 predictors. You can imagine. So I move on to identify the nine strongest predictor that is able to separate my category, that is my response variable, which are cancer and non-cancer, using the Kruskal-Wallis test statistics. And these are the nine variable generated as my strongest predictors. And what does Kruskal-Wallis test statistics does? Kruskal-Wallis test statistics is actually a statistics that helps to check if there is a difference in the median across group. So it's a non-parametric of ANOVA, of one-way ANOVA, because one-way ANOVA is testing if there is a difference between the mean across group, while Kruskal-Wallis is testing if there is a difference between median across the group. Now moving on, this is the box plot representing my strongest predictor. You can see that the median and the interquartile range was able to support that they are actually the strongest predictors that is able to separate my response variable. Moving on to the classification tree, this is a classification tree with complexity parameter of 0.1, generating a tree of four nodes. Wondering why the first strongest predictor variable is not used as the root. Actually, to get the root of a tree is not just based on a predictor that is able to separate my category. It's also based on that predictors that is able to minimize impurity. That is that predictor that contain data points that most of the data points belongs to the same class. So this is what this variable that is being used as roots achieved. So it's able to separate my category, my response variable, and also minimizes impurity. Impurity and just like moving on to the ROC curve. The ROC curve shows a model of 1NN, 7NN, 9NN, and the tree. And from the ROC curve, it's a plot of true positive rates against the false positive rates. And you can see that 1NN actually model has a very high true positive rate despite the low false positive rates. That means it actually performed very well in distinguishing between cancer and non-cancer with no error, of which it is expected according to theory. But this actually suggested overfitting, and it is not good for generalization. But 7NN and 9NN happen to be with a moderate true positive rate, and this suggests to be a biased model. Now, in general, we are not just looking for a model that is complex or a model that is simple, but we are looking out for a model that is able to avoid overfitting and at the same time not underfitting. A model that is able to give us a trade-off between bias and variance in order to make a generalization. Thank you.